All right, so in this, we're going to talk about some basic probability statistics type stuff and some interpreting graphs, data, that type of thing. So first thing we're going to talk about is what's called the fundamental counting principle. And what the fundamental counting principle allows us to do is, like an easy example here would be like number one says if four fair six-sided dice are rolled, how many different pairings are possible? So what the fundamental counting principle allows us to do is it says that the total number of outcomes are going to be the product of each outcome, right? So like what that means is, since we have 4 dice, right? So let's say we have dice 1, 2, 3, and 4, right? So the number of outcomes, since it's a 6-sided die, the number of outcomes for dice 1 is 6, 2 is 6, 3 is 6, 4 is 6, right? 6 possibilities from rolling a die. So what the fundamental counting principle allows us to do is to find the total number of outcomes. It says we just multiply the number of outcomes from each roll, right, would give us the total number. So if we take 6 times 6 times 6 times 6, we get 1,296 pairings. Okay, so you're just going to multiply the number of outcomes for each choice or roll or whatever you're talking about, and that'll give you the total number. So like number 2 says, a coffee shop offers small, medium, and large sizes. Customers can choose between French roast, Italian roast, and American roast. So how many different drink combinations can be created from this menu? So basically there are 2 choices, right? We have a size, and then we have a roast. So the number of choices for size we have small, medium, or large, so 3 times the number of roasts we can choose from. There's 3 roasts, so there are 9 combos we could create, right? Now probability is, with this, remember we talk about it's a percentage, it's a fraction, right? So it's the number of favorable outcomes over the total outcomes. Okay, so in this case it says a bag contains marbles of different colors: 7 blue, 8 red, 6 orange, and 9 white. So what's the probability that John will select a blue marble? So our favorable outcomes in this case is blue, so there are 7 blues, and then the total is, if we add 7 plus 8 plus 6 plus 9, that would give us 30. Okay, so we can't reduce that fraction at all, so it would be a 7 out of 30 chance that he would draw a blue. Okay, what's the probability that Elijah will not select a red? So our favorable is not red over our total. Okay, so if we look at how many are not red, that would be 7 plus 6 is 13 plus 9 is 22 out of the total 30. We can reduce that. We can divide that by 2 and get 11 out of 15. He's got an 11 out of 15 chance of not drawing a red. Okay. 5 says you draw 3 marbles, replacing each one before drawing the next. What is the probability of drawing a red, then a blue, then a white? So we've got 3 draws. So we got draw 1, draw 2, draw 3. So drawing a red would be 8 out of 30. Drawing a, what are we looking at? Blue would be 7 out of 30. And white would be 9 out of 30. Okay, so now this says we're not replacing, we are replacing after each one. So there are 30 marbles each draw, right? And we're going to basically combine this with that fundamental counting principle. So the probability of draw 1 times the probability of draw 2 times the probability of draw 3 would give us our total probability. So if we take 8 times 7 times 9, that gives us 504. 30 times 30 times 30 is 27,000. And again, if you use a calculator to reduce this, I believe we can divide out, what can we divide out? We can divide out 72. So if we divide out 72, we have a 7 out of 375 chance of that specific draw pattern happening, okay? Now the difference in 6, it says you draw 2 marbles without replacing each marble before drawing the next. What's the probability of drawing 2 orange marbles? So same thing, if we look at draw 1, okay, orange, there are 6 orange in a total of 30. So you draw your first one, and then your second draw, you drew an orange the first one, and then you take it out, right? You don't put it back in. So now for your second draw, if we drew an orange, there would be 5 orange left, and then instead of 30 total, there would be 29 because of that. We didn't put that first one back, right? So we do the same thing. 6 times 5 is 30. 30 times 29 is 870. Okay, and then if we reduce that, we can actually divide out 30 and we have a 1 out of 29 chance of drawing back-to-back oranges, okay? Now, next part, mean, median, and mode, right? Remember the mean is just the average. Okay, the median is the middle number. And the mode is the most common or the most occurring number, okay? But in order to do this, usually you have to order your data. That's usually the first thing you want to do. So we're going to order our data. So we're going to write it from small to big, right? So smallest is we've got 4, 6, 8, 9. There's another 9. And then 3 12s. And then 13, 17. Okay. So we order the data. Really, you only need it for the median, but it's just kind of a good idea to order it at the beginning. So remember, for the mean, for the average, right, we add up all of our numbers and we divide by the number of numbers, right? So we're going to add up all of these numbers, okay? And instead of writing all that out, right, we're just going to, you'll be able to have a calculator. So if we add up all those numbers, we get 102. And then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers that we added up to get 102. So if we divide that by 10, our average would be 10.2, okay? The median is where we need to order our data, okay? So for the median, we look at the number in the middle. So basically, to find the number in the middle, just start crossing off from each end. So left, right, left, right, left, right. And then we get to here, and we have 2 numbers, right? There's an even amount of numbers, so the middle would be in here somewhere, right? So what we have to do is, in that case, we actually need to find the average of those 2 numbers. So we take 9 plus 12 divided by 2. 21 over 2 is 10.5. Okay? If there's an odd amount of numbers, then you'll actually have, like, if there was a 10 in the middle here, then 10 would be our median, right? And then the mode is the most occurring number. So if we look, there's only 1 4, 1 6, 1 8. There's 2 9s, 3 12s, 1 13, 1 17. So 12 occurs 3 times. So the most common occurring number is 12. The mode is 12. Okay? So basic things there. And then the back here, looking at and interpreting graphs, all right? So for this first one, we have this graph, and it says how much weight did Carl lose each month? So we've got the months on the bottom, Carl's weight is on the y-axis here. So if we look basically per month, right, that's just your slope. So if we look at, let's say that's there, we got that there, right? So from beginning to end, looks like this is 300, sorry, 0, 300. And this one looks like, let's say, 1, 2, 3, 4, 5, 6, 7. So 7, comma 250. That's what it looks like to me. So for our slope, right, y2 minus y1 over x2 minus x1, right? So if we go 250 minus 300 over 7 minus 0, that would give us, what, negative 50 over 7. And if we do that division, negative 50 divided by 7, oh, my bad. This is, I counted these wrong. We'll start it, we're not starting at 1, we're starting at 0. What am I doing here? So let's try this again. So 0, 1, 2, 3, 4, 5, 6, my bad. So that would make this 6, 0. And that would make these 6. So negative 50 divided by 6 would be negative 8.3 repeating. So he is going to lose, he averages about 8.3 pounds per month is what he's losing, okay? Which month for 11, which month will Carl reach half of his total weight loss? So half of his total weight loss, it looks like, so between 300 and 250 would be about 275. So that looks like that's about in the middle of those two. So that looks like April. He would be halfway there, okay? And then what was the percentage of his total weight loss based on his original body weight? So this is a percent loss thing. So the way we do this is we say the new minus the old over the old. Okay, so his new weight is that 250 pounds. His old weight was 300. And that old weight was 300, so this would be negative 50 over 300, which again, calculator, if we do that, would give us negative 0.167, which would be, the negative just represents it's a loss. So we would say that is 16.7% loss. So of his original body weight, okay? If Carl continues at the same rate, what month will he reach 200 pounds? So he is currently at 250, so he would need to lose another 50, okay? And it took him 6 months to get to that first 50 pounds. So if it's the same rate, it's going to be another 6 months, right? So 6 months from July. So July, August, September, October, November, December. So 1, 2, 3, 4, 5, 6. So it would be, he'd be back to next January. next January, he'd be at 200 pounds. Oh man, that handwriting is terrible. I'm sorry about that. Okay. Now, let's see. This last part says Eric is swimming at a constant rate. The table compares Eric's distance from the starting point in meters and the time since he started swimming in seconds. So how long will it take Eric to swim 63 meters? So 63 meters is not on here, so we're going to need an equation. Okay, so what we can do is, since we have a table here, we can find a slope. Okay, so let's just call this x1, x2, y1, y2, right? So 18 minus 8 over 14 minus 6 would be 10 over 8, which we can reduce to 5 over 4. Okay? So we got that. Now, if we think about writing the equation of a line, right, there's our point slope form. So we have a slope, and let's just use this first point as our x1, y1, right? So we go y minus 8 equals 5 over 4 times x minus 6. Okay? And then let's go ahead, simplify this so we can use it a little bit faster later. Y minus 8 equals 5 over 4x minus 5 over 4 times negative 6 would be negative 30 over 4, which again, calculator, negative 7.5. And if we add 8, okay, so here's our equation we're gonna work with, where x is our time and y is our distance. Okay, so it says how long will it take Eric to swim 63 meters? So this is a distance, so this is a y. So let's plug in 63 for y. Okay, and if we solve for x, so we subtract 0.5. Okay, now to get rid of this, we can multiply by 4. And then divide by 5. So we get x to be 50. So it would take him 50 seconds to go 63 meters, okay? And then it says at 42 seconds, how far has Eric swam? So 42, again, is not on our chart, but 42 seconds is an x value. So let's plug that into our equation for x. So 5 over 4 times 42, 52.5. And then 52.5 plus 0.5 is 53. So in 42 seconds, he would go 53 meters. Okay? So that's what we're looking at with this stuff. Okay, so again, try out that blend assignment and let me know if you have any questions.